Alright, this is Algebra 2 Year 2. This is the partner test that you guys took on Friday. Problem number 1 says if one M&M is randomly selected from a dish containing 7 green, 4 red, 5 blue, and 8 yellow M&Ms, find the probability that a red M&M is selected. So this is just a regular probability problem. So we need to find out how many M&Ms we have total. So we're going to add the green, the red, the blue, and the yellow. So we've got 7 plus 4 red plus 5 blue plus 8 yellow. And we get 24 total M&Ms. And we're looking for the probability that it's a red. So we had 4 red M&Ms that we could pick out of the total of 24. So you get 4 over 24. Now in the directions it asks for a simplified fraction. So this fraction can be simplified. So you get 1 over 6. So 1 over 6 is the fraction that you should have in your answer. When you divide this through, you're going to get a decimal. You're going to get 0.167. So that's your decimal answer. And then to convert that to a percent, you're going to multiply your decimal by 100. So you get 16.7%. And in the directions it does say that your percent needs to be to the nearest tenth. I did accept rounded answers, so if you had 17%, I did accept it. However, the directions do state to have it to the nearest tenth. Number 2. One student is randomly selected from a group consisting of 16 students from LCN, 10 students from Utica, and 9 from Dakota. Find the probability that the student selected is from LCN. So we need to find the total number of students. So we have 16 from LCN, plus 10 from Utica, plus 9 from Dakota. So we get a total of 35 students. And we want to know the probability that we get a student from LCN selected. So there were 16 students from LCN. And then we put that over our total, which was 35. So we get 16 over 35 as our fraction. And that is as reduced as it gets. So you have 16 over 35 as your fraction answer. When you get a decimal, you're going to get 0.457. So your decimal answer is 0.457. And again, converting this to a percent, we're going to multiply by 100. And you get 45.7%. Number 3. A car has 12 choices for outside color, 5 choices for interior design, 3 different tire packages, and 3 different engine sizes. How many different cars can be produced? So this goes back to the fundamental counting principle. So we have 12 choices for outside color. So we're going to take our 12. You multiply by the 5 interior choices, multiply by the 3 tire choices, and multiply by the 3 different engine sizes. And when we multiply through, you get 540. So you can get 540 different cars produced from those different choices. Number 4. Find the number of possible passwords when using 2 letters, followed by 3 digits, then 2 letters with repeats allowed. So this is another fundamental counting principle. So we have 2 letters, followed by 3 digits, followed by 2 letters again. So for letter choices, there's 26 different letter choices. So there's our 2 letters. Then there are we have 3 digits now, and there are 10 different digit choices, 0 through 9. So there's our 3 digits. And then we have 2 more letters. So again, 26 choices for letters. Those are our 2 extra letters on the end. So we have 2 letters, 3 digits, 2 letters. And when we multiply this through, we get 456,976,000. Number 5. Number 5 is a geometric probability problem, and it says, assume that a dart thrown at a circular board shown below will hit the board and that each point on the board is equally likely to be hit. To the nearest 0.1%, find the probability that the dart will hit the shaded area. So, we need to find for our geometric probability, remember that we need to find the probability of the area that we're interested in. So we're interested in this shaded area, which is this square, and we need to find the area of the entire board. So that would be the area of this circle. So, area of a square, remember, is side squared or length times width. You're given that both sides equal 4. So the area of our square is going to be 4 times 4. So we get 16. And then we need to find the area of the entire board, so our total area, which is the entire circle. And I gave you a hint that the area of a circle is pi r squared. So for the area of this circle, we're going to have pi, and our r is given as 5. So we're going to have pi times 5 squared. So this equals 25 pi. So now to find the geometric probability that it'll hit the shaded area, you take your area that you're interested in, or the area you want it to hit, and divide by the total area. So probability of hitting the shaded area equals the shaded area, which was 16, divided by the total area, which was your 25 pi. When you divide that out, you get 0.204 as a decimal. But this wants it to the nearest 0.1%. So we're going to convert this to percent by multiplying by 100. You're going to get 20.4%. On the back, 6 through 9 were pretty much ones that you were just going to plug into the calculator. For 6 and 8, though, I would like to see at least the ratio set up, or the fraction set up. So for number 6, you have a permutation. So to set up the fraction, you're going to have 12 factorial over 12 minus 5 factorial. And then you can either plug this fraction into the calculator or the original problem into the calculator. And to show you again how to plug this into the calculator, you take, to just plug in using the P notation, you're going to go to menu, down to probability, it's a permutation, hit enter, and then you're going to enter the 2 numbers as an ordered pair, so you're going to have 12, comma, 5, enter, so you get 95,040. So number 6 equals 95,040. Number 7 you can just plug in as is. And if you don't remember how to plug that in, you can use the fraction key, which is right next to the 9. This will come up, you'll hit the fraction, you'll have 14. And then to get the factorial, you're going to go again, menu, probability. Factorial is the first one. Go down to the bottom. You have 4. Menu, probability, factorial, times 9. Menu, probability, factorial. Hit enter. You get 10,010. So number 7 equals 10,010. Number 8 is a combination. So if we rewrite that in the fraction form, you're going to get 9 factorial over 9 minus 4 factorial times 4 factorial. Remember that the combination has the extra term on the bottom where the permutation does not. And when you plug that into your calculator, you should get 126. Number 9. Number 9 you can either plug in how you see it here, or you could have simplified it. If you simplified it, you should get 10 factorial times 0 factorial. Remember, 0 factorial is just equal to 1. So you're going to have 10 factorial times 1, which is just 10 factorial. And then simplifying the bottom, you have 10 minus 7, which is 3 factorial, and then times 5 factorial. And when you plug that into your calculator, you get 5,040. Number 10. Number 10 says, find the number of ways 4 people can be chosen out of 10 to be on LCN's Spirit Committee. So this is a combination or a permutation. We have to decide which one. So we're picking 4 people out of 10 to be on a Spirit Committee. Does order matter? Order wouldn't matter for this one because you can pick any 4 people you want. They're not being designated to any specific job, or they're not being picked first, second, or third. So this is just a combination. So order does not matter. So this is a combination. So we're going to use the combination notation, which is the C. And remember that your total set goes first. It goes on the left-hand side. And the number that you're choosing, or the number that you're picking, goes on the right-hand side. So we had 10 people, and we're choosing 4. So again, writing this in the fraction, you're going to have 10 factorial over 10 minus 4 factorial times 4 factorial. When you punch this into your calculator, it equals 210. So there are 210 different ways to choose 4 people out of 10. Number 11. In how many ways can a captain, co-captain, and team manager be chosen from among the 12 members of a volleyball team? So this again is a combination or a permutation. We have to look at and see if order matters. Now for this one, order does matter because we're choosing a captain, a co-captain, and a team manager. So positions are being assigned. So this is like being chosen first, second, or third. So for this one, order matters. So that makes this a permutation. So this is the P notation. And again, your total set, your entire set goes on the left-hand side, so we had 18. And then what you're choosing goes on the right-hand side. And we're choosing 3 different things, so we have a 3. And then again, writing this as the fraction, we're going to have 18 factorial over 18 minus 3 factorial. And when you plug that into your calculator, you'll get 4,896. Number 12. Our display case has room for 10 trophies. If the LCN basketball team has won 24 trophies, in how many different ways can you arrange 10 trophies, 10 of the trophies on the shelf? So we have 24 trophies and we're picking 10 of them. Would order matter? For this one, order does not matter. You can pick any 10 you want. So again, if order doesn't matter, this is a combination. So that's our C notation. So our total number of trophies was 24, and we're choosing 10. Writing that as a fraction, we have 24 factorial over 24 minus 10 factorial times 10 factorial. When you plug that in, you get 1,961,256. Number 13. There are 12 singers left in a round of American Idol. In how many different orders can they perform? So for this question, we're only given the one number. We're given that we have 12 singers. So that it should immediately get you thinking about a factorial. And we're ordering something. So we're going to have 12 singers to start with. Once we've picked our first singer, then we'll only have 11 singers left. Pick another one, then we only have 10 singers left, and so on until we only have 1 singer left. So that was where we had 12 times 11 times 10 times 9, so on until we got to 1. And that was 12 factorial. That was what 12 factorial meant. And 12 factorial equals 479,001,600. And then our last problem, expanding the binomial. So you could use either Pascal's triangle or the combinations. I'll show you the setup for both ways, and then they simplify to equal the same thing. So if you're using Pascal's triangle, you're going to look at the 5th row, because we're taking this to the 5th power. So the coefficients that you would get are 1, 5, 10, 10, 5, and 1. So now you're going to actually use these. So you'll have your first coefficient, which was the 1, times your first term, which is an x, And this x is going to be to the power that we're raising our binomial to, which is the fifth. And then our second term is a 4. So our second term is going to be 4. And remember that this is to the 0 power, and it increases each term. Our binomial is a subtraction, so our signs alternate for this one. So in between our first and our second term, we're going to have a negative or a subtraction sign. And then our next term, our coefficient is 5. Our x exponent goes down by 1, so it's x to the 4th. Then we have our second term was the 4 to the first power, because it's increasing by 1. Alternating our signs, now we have an addition. Our coefficient for our third term is the 10. Our x is to the third now. 4 is being squared. Our next term we're subtracting because we're again alternating our signs. Our coefficient is 10. X is squared now. 4 is being cubed. Adding our next term, our coefficient is 5. X to the first, 4 to the 4th. And our last term, our coefficient is the 1. X is to the 0 power now, and 4 is to the 5th. So now we need to simplify this. So for our first term, we have 1 times x to the 5th times 4 to the 0 power. 4 to the 0 power is 1. So you have 1 times x to the 5th, which gives you x to the 5th. Bring down your subtraction sign. Now you have 5 times x to the 4th times 4 to the first power. 4 to the first power is just 4. So you have 5 times 4 is 20 times your x to the 4th. Bring down your addition sign. You have 10 times 4 squared. 4 squared is 16. 16 times 10 is 160 times your x cubed. Bring down your subtraction sign. You have 10 times 4 cubed. 4 cubed is 64. So you have 64 times 10 is 640 times your x squared. Bring down your addition sign. You have 5 times x to the first power times 4 to the 4th. 5 times 4 to the 4th is 1,280 times your x to the first, which is just x. And our last term, you have 1 times x to the 0. X to the 0 is just 1. So you have 1 times 1 times 4 to the 5th. 4 to the 5th is 1,024. So this is the simplified version of the binomial being expanded. Now, instead of using Pascal's triangle, you could also use the combinations. The only thing that would change would be your coefficients. So instead of having the coefficients there, you would start out with the combination of 5 with a 0 times your x to the 5th, 4 to the 0. Again, subtraction, because we alternate our signs. We'd have 5 and 1 for our next combination. X to the 4th, 4 to the 1st. plus our next combination would be a 5 and a 2. Remember, these are not fractions. These represent the combinations. So the first one was C5, 0. This one is C5, 1. Those are not fractions in the parentheses, they represent combinations. So our next term, the combination would be 5 with 3, x squared, 4 cubed, and our next term is 5 with a 4, x to the 1, 4 to the 4th, and subtracting our final part is 5 with a 5, x to the 0, 4 to the 5th. And that's how you would write it out using the combinations notation. And it would simplify exactly the same as the Pascal's triangle. So you would still get the x to the 5th minus 20x to the 4th, and so on.